Today's lesson is about analyzing graphs of functions. Before we analyze this graph, we need to know some concept of functions. First of all, even and odd functions. For today's lesson, since we just analyzed the graph of functions, you just need to know how to identify a graph of a function is even or odd. If a graph of function is symmetric with respect to the y-axis, we call this function is an even function. If it's symmetric with respect to the origin, we call the function is an odd function. Therefore, according to this definition, we can decide the following graph of functions are even or odd. For the first graph, since it's symmetric across y-axis, therefore this is an even function. For second graph, since it's not symmetric across y-axis and it's not symmetric across the origin, therefore this is neither, which means it's not even or odd function. For last one, this graph is symmetric across origin, therefore this is an odd function. Now let's talk about the definition of a local maximum and a local minimum. For local maximum, if and only if there is an open interval I containing A for which f of A greater than equal to f of x for all x in I, then f of A equals B is called a local maximum value. According to this definition, we could say that open interval is a very important concept for local maximum. Therefore, in the following situations, there is a local maximum. We have local maximum over here because we can form open interval. We have local maximum here because we can form this open interval. We do have local maximum over here because we can form this open interval. We have a local maximum for these points because we have this open interval. For horizontal line, we can form this open interval. So horizontal line is a local maximum too. On the other hand, for local minimum, we can think about the following situations. This point will be local minimum because we can find out an open interval. This is local minimum for this open interval. This is a local for this open interval. This will be local minimum for this interval. And a horizontal line, it will be local minimum because we can form this open interval. In other words, for horizontal line, they are both local maximum and a local minimum. When we talk about maximum, basically means absolute maximum, which means the highest points of the graph. For minimum, that means absolute minimum, means the very bottom points of the graph. Now let's talk about increasing, decreasing, or constant function. Constant function is really easy to understand. It's just a horizontal line. That's constant function. For a given graph of a function, you have to see from left side to the right side. And the graph going up means increasing. When the graph is going down, we call that part of a function is decreasing. For example, this is an increasing function because from left to the right is going up. See, this part is increasing. For this graph, this is increasing. From here to here, that's increasing. From here to here, this is increasing. Which part of a function is decreasing? From left to the right, it's going down. The graph is going down. So this part is a decreasing function. This is a decreasing. This is a decreasing. When you analyze a given graph, you need to figure out which part of a graph is going up or going down. So you decide which part is increasing and decreasing. Then you need to figure out domain of each part. Now we analyze this graph. For number 1, find the domain of f. Number 2 is find the range of f. Let's talk about domain and a range of a graph. How to remember domain and a range? I use Dixit to remember. Domain means x value, means independent variable. We use the different terms, means exactly the same thing. For range, we could see that's a y value or dependent variable. When you talk about dependent variable means range, means y value. If you are given a graph, you need to figure out the very left point and a very right point to find the domain. For range, you just need to find out the very bottom points and the very top points to get range. Therefore, for number 1, find the domain of f. Domain, that means x value. X-axis, that's horizontal. So we need to find the very left point. It's over here. Very right point is over here. I need x coordinates. So we got -4 and 6. We use interval notation to show the domain. Basically, this is the meaning for this interval. X will be between -4 and 6. For range, you need to get the very bottom points. It's over here. Then you draw a horizontal line to figure out the y coordinates. That's -8. Very top point is here. Then that's 5.5. It's given. So range will be between -8 to 5.5. The meaning for this interval notation, it is y is between -8 and 5.5. For number 3, list the x-intercepts. Intercept means crossing x-axis. So you need to find out the points that the graph crossing x-axis. We got 3 points. 1, 2, 3. Before we do the Xintercept, let's clarify some more concepts. When we talk about Xintercept, that means zeros of functions, means root of a function or solutions of function. So we use all these 4 different names to show exactly the same thing. Normally for SAT, they use zeros a lot. Now let's go back for number 3, Xintercept. If it's not integers, let's estimate. This is negative 3.7. This is 0. This one is 5.6. So for Xintercept, we need coordinates to show Xintercept. So we got negative 3.7, 0, 0, 0, and a 5.6, 0. For number 4, list the y-intercepts. The line cross y-axis at 0, 0. So y-intercept is 0, 0. Find the zeros of f. Basically, for number 3 and 5 means the same thing. Normally, for zeros of a function, we list all x-intercept. So we got the x equals negative 3.7, 0, and a 5.6. For number 6, solve fx less than 0. Fx means y. Y less than 0 means we need to look for those parts of a function whose y coordinate is negative. So which part of a graph whose y coordinate is negative? Y coordinate is negative, it will be below x-axis. Look at this. This is the y coordinate is negative. In other words, for fx less than 0, we need to figure out the domain of parts of the graph below x-axis. When fx greater than 0, we need to figure out the domain of parts of the graph above x-axis. Therefore, first of all, we need to find the parts of a graph below x-axis. First part from here to here. Then this will be the second parts. Altogether, there are 2 parts of the graph is below x-axis. Then you need to figure out the domain for each part. For this part, we know domain is between negative 4 to negative 3.7. Since for fx is less than 0, no equal sign. As we know, for x-intercept, that's f of negative 3.7 equal to 0. Therefore, negative 3.7 is not the solution. So it's open parenthesis. For second part, domain will be between 0 to 5.6. It's still open interval. That's the solution to this inequality. For number 7, determine f of 2. We know the fx. Now we know f of 2, which means x equals 2. For x equals 2, you need to find out 2 on the x-axis. It's over here. Then you need to draw vertical line to intersect this graph at 2, negative 7. For any points of the graph, we know that xy, we can write down f of x equal to y. Therefore, for 2, -7, which means f of 2 equals -7. So f of 2 equals -7 for number 7. For number 8, fx equals -3. fx means y. So on the y-axis, we need to find out this -3. Then you need to draw a horizontal line. Intersect the graph 3 times. So we can get 1, 2, 3. You will have 3 solutions. X equals -4. You will get this is 1. Then here, just estimate. Let's do 5.2. For number 9, find the number of solutions to fx equals 1. Basically, we are not looking for what the solutions are. We're looking for how many solutions to f of x equals 1. You will find the 1 on the y-axis. It's here. Then you need to draw horizontal line. Just check how many intersections you get, then how many solutions you have. We have 1, 2, 3 intersections. So for number 9, 3 solutions to f of x equals to 1. For number 10, according to this graph, is it even, odd, or neither? As we know, even functions are symmetric across y-axis. Odd function is symmetric across the origin. For this graph, it's not symmetric across y-axis, it's not across origin, so it's neither. For number 11, list the intervals on which f is increasing. So look at the graph from left to right. Which part of graph is going up? We got from here to here. This part and also this part. It's increasing because the graph is going up. Then you need to figure out the domain for each part of a graph, which is going up. For this part, we know domain is from -4 to -2. This part is 3, 4. This part will be from 5 to 6. Therefore, for number 11, we got -4 to -2, 3 to 4, and 5 to 6. For number 12, list the intervals on which f is decreasing. So on the graph, you need to find the part of a graph which is going down. You could say this part of graph. It's going down. The domain for this part of graph, that is from -2 to 3. So we only get one part of a graph is decreasing. Domain will be between -2 to 3. Horizontal line, this part, that's constant. It's not increasing, not decreasing. For number 13, list the local maximum. According to the definition of a local maximum, we could say this is a local maximum. This is a local maximum. For horizontal line, open interval between 4 to 5, we have local maximum that is -6. Therefore, I will write down f of -2 equals 4.5. That's a local maximum. F of 4 equals -6. And fx equals -6 when x is between 4 to 5. For number 14, list the local minimum. For the local minimum, we know this is a local minimum. This point is a local minimum. And also for open interval, horizontal line is also count the local minimum. So we get f of 3 equals -8. That's the local minimum. F of 5 equals -6. And also f of x equals -6 as x greater than 4, less than 5. For number 15, find the maximum. That means the absolute maximum. You need to find the very top points of the graph. We do have 6, 5.5. So we write down f of 6 equals 5.5. For number 16, find the minimum. That means the absolute minimum. Therefore, we need to figure out the bottom point. That's a very bottom point is 3, -8. Therefore, we got the f of 3 equals -8. Let's look at one more example. For this given graph, find the domain. So we need to find out the very left point, that's -4. Very right point, that is 4. So we got -4 to 4. Find the range. We need the very top points and the very bottom points. We got the very bottom points, that's -5. Very top point, that's 5, but that's open circle, means this value is excluded. Therefore, we got the 5, that's open parenthesis. Determine f of 2, so find the 2. Then we draw vertical line. This is a closed dot. That means equals to 3. For f of x equals -5, we need to find the -5 on the y-axis. Then you draw horizontal line. It's this point. So you get x equals -2. List x-intercept. That's 1, 2, 3. So we got -4, 0, 0, 0, and 4, 0. Y-intercept. The graph crossing y-axis at 0, 0. Find the zeros of f. That means x-intercept. Therefore, x equals -4, 0, and 4. Solve fx less than or equal to 0. Less than or equal to 0 means we need a graph below x-axis. So we find the part of the graph below x-axis is from here to here. Since we have equal sign, means all x-intercept counts. Also, this 4 count. Therefore, we got from -4 to 0. That's the domain for the part of graph below x-axis. -4 to 0. That's the domain for this graph. Then you need to add this 4 because you have equal sign. Means all x-intercept still count. For number 41, find the number of solutions to fx equals 3. So find the 3, you draw the horizontal line. Intersect the graph at 3 points. So we have 3 solutions to fx equals 3. It's not even, it's not odd function. It's neither. Because for these points, you cannot find out a point over here that is reflect across origin. Therefore, it's neither. For 43, list the intervals where f is increasing. So you need to check from left to the right. The graph is going up. We got this one. It's going up. Domain for this part of graph, that is from -2 to this 2. But 2 is open parenthesis because this is an open circle. Therefore, we got from -2 to 2. Which part is decreasing? We have 2 parts. It's decreasing. So for the domain of the 2 parts of graph, it will be between -4 to -2. This part, you got the 2, that's an open parenthesis from 2 to 4. 4 is a bracket. Therefore, we will write down from -4 to -2, and also from 2 to 4. For 45, local maximum. We don't have local maximum because this part is an open circle. That means none. For local minimum, we got these points. That is f of -2 equals -5. And also, this point is a local minimum because for this open interval, these points 2, 3 is a local minimum. So we write down f of 2 equals 3. We don't have a maximum because this is an open circle. For 48, find the minimum. We do have very bottom points. That is f of -2 equals -5.